All right, let's continue to be radical. All right, so far we've talked about what a root is. We talked about how to change forms between exponent form and radical form and exponent form. We looked at how to simplify radicals. Most important lesson, because in almost everything we do, simplification is part of that. And so today's lesson, in dividing radicals, we have to be concerned about simplifying as well. All right? We multiplied radicals, and now we're getting ready to divide them. All right, so first off, what is the general rule in division when you have a fractional radicand? So that's this rule right here, and you can see we have a fraction as a radicand, and it's real simplistic. It's the root of the numerator of the radicand divided by the root of the denominator. And honestly, I'm going to take my black and I'm going to add an n index, because not only square root, cube root, fourth root, so the nth root of x divided by the nth root of y, right? There's an index. So square roots would be square root of the top divided by square root of the bottom, cube root of the top divided by cube root of the bottom, etc., 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 etc. Pretty simplistic rule. We're simply going to take the root of top and bottom. So when you work your way through a couple of these simple problems, not a whole lot here, right? So this first one, you're just going to do the square root of 4 divided by the square root of 9. That's pretty easy, right? And let me refresh your memory. With numbers, we generally only give the principal root, the positive answer. Though technically, there's a negative answer as well. But again, with numbers, we usually only just give the positive. All right, so square root of 4 is 2. And the square root of 9 is 3, and that's simply 2 thirds, right? 2 thirds. So something like b, all right, not a problem. Square root of 2 divided by the square root of 25. And again, you're going to simplify where you can, right? So this thing's just going to stay on the top as a square root of 2, and the bottom's going to be a 5, right? Square root of 2 over 5. Nothing difficult there. Nothing earth-shattering. Nothing of concern. All right, so why don't you go ahead and try to do C and then D. Go ahead and do C and D. And as you're working, I'll go ahead and do them up here as well. So simplify, 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 simplify. Things on the top stay on the top, right? Things on the bottom stay on the bottom. So on C, you should have ended up with 2x squared times the square root of 2x over y cubed. Remember, an 8 is a 2 times 4. Square root of 4 is 2. You get a 2 out. X to the 5th would be x to the 4th times x. Square root of x to the 4th is x squared. Or again, you can break it up in x squared times x squared. Bottom, y to the 6th, y squared times y squared times y squared is y times y times y, or y cubed. All right, and then hopefully you did that same concept to the other one. By the way, what's the square root of 1? What's the cube root of 1? What's the 100th root of 1? Okay, that's 1. Any root of 1 is 1. And on the bottom, square root of 9, we all know is 3. And what's the square root of n to the 12th? n to the 6th. Again, because 12 is divisible by the index 2, you could just divide the 12 by 2. And you're taking the root, right? You're doing the change in the form and doing it in one quick shot. Or you can do it the long way, n squared times 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 n squared, which is still n to the 6th. Is everybody okay with those? Questions on any of that? All right, but don't forget you separate numerator and denominator. Take the root of top, take the root of the bottom. All right, well that leads us now to what becomes an important aspect. The bottom of a fraction cannot remain as a radical. You might say, why not? Because the radical police will issue you a radical citation and it will radically alter your grade. Right? So if you leave a radical in the denominator, the radical police will issue you a radical citation and it will radically lower your grade. You just can't. You cannot leave a radical in the denominator. It's not a proper form. It's just not proper form, and therefore we have to take care of that. And the method to do that is called rationalizing the denominator. So I'm just going to say rationalize the denominator. R-A-T-I-O-N-A-L-I-Z-E. Rationalize the denominator. You'll hear me say that a lot. Hey, don't forget to rationalize the denominator. Oh yeah, in this situation we have to rationalize the denominator. The methodology of rationalizing the denominator is simply figuring out a way to take the root of the denominator. And the concept is on par with equivalent fractions. Because aren't we dealing with fractions? So before I do anything, just concept, right? Don't write this. If I had 3/5, if I want the denominator to be 15, I'm going to multiply the bottom by 3, right? And whatever I do to the bottom, got to do the same thing to the top, right? And I'm going to multiply it by a form of 1, and I'm going to change its form. It's going to now be 9/15, but it's still 3/5 in different form. That's what we have to do to rationalize the denominator to get rid of the radical in the denominator. We're going to change the form. And we are going to multiply by a form of 1. Because anything times 1 is the same thing. Multiplicative what? Property? Identity, right? The identity property. And so that's the concept. Okay. So just like with fractions, this is where you're looking. That's where your focus is. Now you can write that because this is the key. That's where you're looking. You're concerned about the denominator, the radical in the denominator. And we're going to rationalize the denominator. So I have to figure out what can I multiply this thing by to get rid of the square root in the denominator. That's the question. Square root of 7 times what will get rid of that radical sign? That's the question. Who's got an idea? Who's got an idea? Who's got an idea? Come on, think. What would you do? What would you do? What would you do? Connor, what would you do? 7. So multiply it by 7. Don't do anything yet. We're just thinking. Just like that. And whatever you do to the bottom, do the same thing to the top. So is that what you want to do? So like this, and therefore then like that? Is that what you want to do? I'm just asking. I'm not trying to, I'm just saying, is that what you want?
Sure.
Anybody agree with Connor? We got 4 of you, 5 of you, 6 of you, 7, 8. All right, jump on the bandwagon while the jumping's good. Let me ask you this. Let's just worry about the bottom. What is the square root of 7 times the square root of 7?
Square root of 49.
Well, I wouldn't put it that way personally, but you can if you want. How about if I left it the square root of 7 times 7? Because remember, we got to deal with variables as well. What's the square root of 7 times 7? Okay, if you want to play that game, what's the square root of 49? Yeah, okay, thank you. All right, why are you going to multiply it out when you got to find 2 of something to take the square root? Did we indeed get rid of the radical sign in the denominator? We did, and that is the proper way to rationalize that. So, and our top ends up with 3 times the square root of 7, right? And so our final answer is 3 times the square root of 7 divided by 7. And that's the final answer form. That's a acceptable form. Yes, we can have radicals in the numerator, but we are not allowed by the radical police to have a radical in the denominator. Otherwise, the radical police will issue you a radical citation, and it will radically alter your grade. Okay? So again, where are you looking for B? At the denominator. That's your focus. It's all about the denominator. Antonio, what would you multiply the bottom of this one by?
Square root of 5.
Square root of 5. Anybody concur? That is what's going to get us to get rid of that radical in the denominator. And honestly, guys, most people are going to go on the first step. Square root of 5 times square root of 5 is 5. It's 5. Okay? Square root of 5 times the square root of 5 is 5. And the top is going to end up being square root of 10. No simplifying, but you know what? I'm thinking about it. It's in my mind. It's on my radar. It's in my thought process. That one didn't happen to simplify in the top. Sometimes they will, and I'm going to be aware of that. I'm going to look out for that. So rationalize in the denominator. All right, so let's do a few more examples here. So C starts out with a fractional radicand. So the first step of C is to split it up, right? Now, look, most students know that the top's going to be the square root of 4, and the square root of 4 is, so most are going to write the 2 right there and put the square root of 5 on the bottom. All right, finish that off while I finish it up here. Rationalize your denominator. Finish it off. And hopefully you think it's 2 times the square root of 5 over 5. Does that make sense? We're just rationalizing the denominator. Now D is a little unique. Sometimes don't be so quick to split it up. Because what can you tell me about the fraction? Alexandra? It's not reduced. And it can be reduced. Why don't we reduce it? So right before we split it up, why don't we reduce it? And hopefully you agree it's a 1/3. Okay, now finish it off. So now you got the square root of 1, which is 1, over the square root of 3, right? And then you're going to rationalize the denominator. And this thing ends up being the square root of 3 over 3. Now, if you don't do that, if you don't reduce it first, you'll end up in the same place, but you'll make the problem a lot more difficult. Don't make it more difficult. It's not worth it. Not worth it. Everybody good so far? All right, let's keep rolling. So E is going to be the square root of 3 over the square root of x. So, Eduardo, what do you want to do to this one to rationalize it?
Multiply square root of x.
Yeah, right? We got a square root of x on the bottom, so let's get another square root of x, because square root of x times square root of x is x. And of course, whatever you do to the bottom, do the same thing at the top. What does that make our bottom? X. And Lauren, Carr, what do you get on the top?
Square root of 3x.
Yeah, square root of 3x, right? We're going to multiply our radicands. And again, in none of these, we didn't have any simplifying yet. We'll get to those problems soon. Okay, so one more progression here as I try to take you guys through some of the possible variations that you're going to see. So in F, we're going to split it up, right? Square root of 2 over the square root of 7n. And Pamela, how would you rationalize that one? And hopefully everybody's thinking, right? How would you rationalize this one? Okay, so anybody agree with square root of 7n? And that's correct, right? We need one more 7, we need one more n. And anyhow, the square root of 7n times the square root of 7n is 7n. And our radicand ends up with the square root of 14n, right? And remember, can you reduce this 7 in the bottom with the 14 in the top? No, because the 14 in the top is underneath the radical sign, right? It's tied to that radical sign. Anything outside, yes. Anything inside, no. 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 Okay, let's step it up. For cube roots, don't lose fact of what a cube root is. The index is 3. Therefore, you need 3 of each factor to rationalize the denominator. I will tell you this. For some reason, students have a hard time wrapping their mind around how to rationalize efficiently a cube root. Let's see if we can get through it. So again, where am I looking? I'm looking at the denominator, right? That's your focus. That's your concern. I'm going to multiply it times the cube root, and don't say anything of what. So everybody thinking. Everybody thinking. Multiply by the cube root of what? Who wants to give it to me? Cube root of what? Raquel? 5? Like that? Agreed? How many agree? Okay, so let's hold off in your notes. Let me finish this. Whatever you do to the bottom, do the same thing to the top. So tell me, what are we getting the bottom right now? Cube root of 25, right? Isn't that the bottom? Have we gotten rid of the radical in the denominator? The answer is no. So maybe the key is paying attention to my opening statement for this section, number 3. All right? That might be important to pay attention to my opening statement. All right, so we got to try something else because that didn't work, and rightly so, because this is a cube root, and therefore that's not going to work. Adam, what do you want to try? 125? I'm not going to take the time there. You're overthinking it, making it harder than it is. Nick?
Times cube root of 25.
Okay, how about if I instead say the cube root of 5? Let me get my green here. Nick said the cube root of 25. How about if instead I say the cube root of 5 times 5? Isn't 5 times 5 25? Why did I want to say 5 times 5 instead of 25? Why did I say it that way? Ethan?
Because it's showing that you have 2 5s in there times the 5 underneath the 3.
For a grand total of 3 5s, right? What are you after? 3 5s. How many do we have to begin with? 1. How many more 5s do we need? 2. We need 3 5s, right? Don't we? We do. So now, whatever I do the bottom, I'll do the same thing. Hey, the top I can make the cube root of 25 because I'm not worried about anything up there. You can leave it 5 times 5 if you want. So again, now, what is the cube root here? I'm going to take the moment to write the middle step. 5 times 5 times 5. See, we ended up with 3 5s, which is what we need for cube root. And the top is 3 times the cube root of 25. Final answer. 3 times the cube root of 25 over, what's the denominator? 5. The cube root of 5 times 5 times 5 is 5. Awesome. That's the concept. Let's go to the next one. Again, my focus is the denominator. It's a cube root, so I have to multiply by a cube root. So again, I need to ask you, don't say anything out loud. What would you do to the denominator to rationalize the denominator? Now, there's a best answer. What would you use to rationalize the denominator? What would you have? Cube root of what? All right, so on 3, I want you to say out loud what the what is. So I'm asking you for the cube root of what? All right, you're going to say what is. Got it? Clear? On 3. 1, 2, 3. Okay, I heard 4, right? Did I hear anything other than 4? Did I hear 4 times 4? How many are my 4 times 4 people? Okay. And I heard something, so I heard a single 4. Who are my single 4 people? Okay, you don't have enough 4s. You only have 2 4s now. How many do you need? 3. 2 is not 3, all right? So if you just do 4, it's not going to work. Now, you people that did 4 times 4, you do have 3 4s now, right? That'll work. That's not the best way to do this problem, though. Because I heard something else. Adam? 2. I heard 2. 2 is the best way to do this problem. Huh? What? Because again, you guys, radicals, you're looking at the radicand and you're thinking of factors, right? Because simplifying radicals is all about the factors. I already had 2 2's, didn't I? Isn't a 4 a 2 times 2? What's the most efficient way to do this? Do the cube root of 2 on the bottom. I need a third 2. Whatever I do at the bottom, do the same thing at the top. All right, I'm going to use a little color here. The top is 6. I'm going to keep that red, times the cube root of 2. And what's the bottom? 2. Am I done? On this one, I'll do what? I will reduce the 6 and the 2, right, and get a 3. So the final answer of this is 3 times the cube root of 2. Because in this one, the fraction part happened to reduce. And I will reduce it when it can. Now, I don't want you to put this next one in your notes, but I want you guys to watch. Let me show you what happens if you use the 4s, and you can. But here's what's going to happen. I'm just going to show you. Don't write, just watch. Do not write, just watch, because I'm going to go too fast if you write. Just watch. So if you go 4 over 4, some of you aren't watching. I don't know why you're not watching. Whatever you do at the bottom, do the same thing on the top. Okay? Whatever you do on the bottom, do the same thing on top. What is my bottom going to be? A 4, correct? What will most people write on the top? 6 times the cube root of 16. Then they'll do this. 2 and 3. Is that the same answer? Because they'll miss the fact that they can further simplify the numerator of the radicand of the numerator. What's a 16? 2 times 8. What's the cube root of 8? 2. Now I end up with 2 times 3 times the square root, cube root of 2. Now my 2's divide out, and where do I end up? 3 times the cube root of 2. Did I end up in the same place? Are there many pitfalls that a student's going to miss and not get the correct final answer? Yes. It's not the wisest way to do the problem. So again, you're missing understanding. Cube roots, we're looking for 3 of something. If I already have 2 of a factor and I only need 1 more, that's the simplest way to approach the problem and the most efficient way to approach the problem. And because it's more efficient, there's also less opportunity for error. All right, so let's see if we can keep working through these cube roots. So now let's look at C. So again, in your mind, you're going to determine what you're going to multiply this by. It's got to be a cube root. So you're thinking, what do I multiply the denominator by? Cube root of what? Cube root of what? And you want the most efficient thing to rationalize the denominator with. Let's see. Adriana, you've been quiet. What do you want to do on the bottom to rationalize? Cube root of 3? Just like that? Okay. I like your 3. But what's going to happen to our x? It's going to still be there. You got to take care of your x as well. You properly took care of the 9, seeing that your 9 was a 3 times 3, and you already had 2 3s, so you did well there. How are you going to take care of the x? How many x's do you have, Adriana? How many do you need? So supply the other 2. What's the other 2 x's? It certainly is, right? Isn't it? Do you now have 3 x's as well? You do. You now have 3 3's. You now have 3 x's. They're separate entities because they're multipliers. Say the denominator if you know it. What's the bottom going to be? 3x. Right. We have 3 3's and 3 x's. We get a 3 out. We get an x out. Look at the top. The top is going to be the cube root. We already have 1 5 and 1 3, so we don't have 3 of anything, right? So that's a 15. And we have an x squared. We don't have enough x's. And that's the cube root of 15x squared over 3x. Does that make sense? Again, you got to take note of what am I dealing with. It's a cube root. I need 3 of everything. It's not a square root. Can't treat a square root like a cube root. They're different. Square root, I need 2. Cube root, I need 3. Again, I don't understand why this is difficult for students, but I know it is. Because you're not just quite understanding what's going on somehow. But square root, you need 2 of them. Cube root, you need 3 of them. All right, 2 and 3. All right, D's a little unique. So again, we'll split it up. Cube root of 7 over the cube root of 20n squared. And now we'll rationalize. Cube root of 7 over the cube root of 20n squared. Right, I just split it up. Now, how would you rationalize that one? How would you rationalize that? Now, if you went 20 times 20 times n, you got a mess. It'll work, but I doubt you're going to come out to the simplified answer. What's it all about? Seeing how many things you have in the bottom, right? Right? Yes? Natalie, what do you want to try to rationalize it with? You got to speak up. I can't hear you. Let me ask you this. When you factored the 20, what did you get? Okay. It's good. And Natalie, did you factor the 4 into a 2 times 2? Okay, good. All right, so Natalie, looking at that, how many more 2's do we need? How many 2's do you have? How many more do you need? How many total do you need? No, okay, so again, see, somehow you're missing this. This is a cube root, Natalie, right? How many of everything do you need? Okay, right, so you have 2 2's, you need 1 more. All right, so you need 1 more 2. How many 5's do you have right now? How many more do you need? 2 more, exactly. So 5 times 5. All right, takes care of our numbers. How many n's do you have? How many more do you need? There you go. And now you have what you need to take the root of the radicand. And whatever you do the bottom, do the same thing to the top. 2 times 5 times 5 times n, right? Make sense? See how many you got and provide the right amount to get you to 3. All right, so I'm looking at my top, and nothing's going to simplify on my top. So 5 times 5 is 25, times 2 is 50, and 50 times 7 is 350. Use your calculator if you can't do it in your head. That's 350n over, what's our bottom going to be? What's the bottom going to be? Ashton, what's the bottom going to be? Okay, what's the cube root of 2 times 2 times 2? What's the cube root of 5 times 5 times 5? What's the cube root of n times n times n? Okay, so that looks like 10n to me, right? Right? So the bottom is going to be 10n. And we end up with the cube root of 350n divided by 10n. Look, just do it one step at a time. Factor that denominator in the radicand and see how many you need of each thing for cube roots. All right, so let me show you some other interesting problems and try to give you some food for thought here in how to go about trying to analyze something. So at times, it's to your advantage to combine them back into a single radical so you can reduce. Now, this is just something you have to be aware of and you have to look for. So I'm trying to give you the thoughts to think. So when I get to problem A, you guys all looking at either the board or your sheet, either way is okay. You see A, you see how I got a 70 on the top and a 10 on the bottom? Does that reduce? It does. So you know what? I want to stick this back together. It's going to make life so much easier. Because look, 70 divided by 10 is 7. And you know what? We're done. Square root is 7. I don't even have to do anything else on that one. Gee, wasn't that better than rationalizing and multiplying it by the square root of 10 over the square root of 10 and getting the square root of 700 over 10 and then go ahead and simplifying that? You're going to be there like 5 more minutes. And we just did 70 divided by 10 is 7. We reduced it. You follow? You got to be thinking that way. You got to be looking for that possibility. So again, now I look at B and I say, okay, I'm looking at B. What am I going to do with B? And so hopefully you say with B, I'm going to combine it and reduce it. Right? 3x over 6x. Hey, be careful. The top is a 1 and the bottom is a 2, right? So just to be clear on this, do you agree we're at the square root of 1 divided by the square root of 2? Don't make something in the bottom magically come to the top because there's a 1 in the top. It doesn't. So finish it. Finish it. Finish it. Right? It's all about the index. I am now doing a square root. How many do I need? 2. How many do I have? 1. I need a second one. Whatever I do the bottom, do the same thing the top. And this is square root of 2 over 2. How many got that correct? Okay. Just keep track of square roots and cube roots. All right, so let's do this last one as a cube root. Put a 3 index in. Oh, we're in the elementary format here. Elementary format with the division symbol. This is the way I would do this problem. This were my quiz paper or test paper. I would draw a line a little bit under that one, and I'd stick the 6a squared, b squared, a cubed, I'm sorry, b squared c underneath of it. And now I'd reduce that fraction, right? This is all underneath the cube root. Now again, some of you guys struggle on these, but this should be a pretty simplistic thing. How do you reduce a 12 on the top with a 6 on the bottom? What do you end up with? On the top or bottom? Top, right? So that's a 2 on the top. Let's now go to our A's. I'm going to do these in green. You got an A squared on the top and an A cubed on the bottom. What does that leave you? An A squared on the top and an A cubed on the bottom leaves you a what? An A in the top or the bottom? The bottom, right? Because there's 3 of them in the bottom, 2 of them on the top. That leaves you 1A in the bottom. You know, let me off to the side again. I know some of you struggle. An A squared divided by an A cubed. What's an A cubed? An A times A squared. The A squareds divide out, leaving you what in the bottom? An A. But the simple thing is there's 2 in the top and 3 in the bottom. The 2 in the top wipe out 2 of the 3 in the bottom, leaving you 1 in the bottom. That's all that's happening. What about our B squareds? They're gone, right? You got a B squared in the top and a B squared in the bottom, right? They're gone, right? What about our C's? Is that a B cubed? Oh, the eyes are failing me. Look, eyes. All right, sorry about that. So if I have 3 B's in the top and 2 B's on the bottom, what does that leave me? A B where? Top or bottom? Top, where the 3 of them are, right? So we got a B in the top. And how about the C's? All right, those we have. 1 C on the top, 1 C on the bottom. They're gone. All right, let's rewrite to be clear and split it up. So what's my top? The cube root of 2B, or not 2B? That is the question. And the bottom is the cube root of just A. That's all that's left in the bottom. And now we'll need to finish it. Alexis, question. Or what? No, there's 1 C on the top, 1 C on the bottom. Say again? We're doing a cube root, but right now we're just reducing the fraction. See, we're not rationalizing anything yet. We're not simplifying anything yet. We're just reducing the fraction. Now in this step, now we're worried about what kind of root we have. All right, finish it off. Finish it off. Rationalize it, finish it. By the way, quiz tomorrow, of course. Quiz mañana. Think about what you have. And I hope you did the cube root of A squared. You had 1A, you need 2 more A's, folks. Final answer, cube root of 2A squared B divided by A. Who got that one right? Okay. And again, that's what you're got to keep track of your index. All right, homework's written, quiz mañana. Homework, quiz mañana. Always review your first quiz. Second quiz will involve material from the first, and since we have 1 topic left, 1 topic to go.